Hello, my name is Mojmír Kučera, and I would like to invite you today uh, to another Dayton Progress webinar, this time together with our long-time business partner, Oerlikon Balzers. As you probably know, Dayton Progress is a manufacturer of die components, and Oerlikon Balzers is one of the world's leading manufacturers of coating technology. But before, let me introduce some of our guests. So let me introduce our guests and experts. First, I'd like to introduce Dennis Dietrich, sales manager of Dayton Progress from Germany, who today tells us about challenges and solutions in aluminum stamping process. Hi, Dennis, how are you today?
Thank you. I'm fine. And hello and good afternoon to all our viewers.
Yeah, perfect. Another guest is Pedro Faro, sales manager of the Oerlikon company from Portugal, who today tells us something about the connection between Dayton Progress and Oerlikon Balzers and a little about the coatings we produce at our plant in Portugal. Hi, Pedro, how are you?
Hello, I'm fine. And with good weather in Portugal, 20 degrees, so we
Okay,
can. I'm fine.
okay,
Okay, thank you.
okay. And finally, today, webinar special guest, Dr. Vishal Khetan, Global Customer Solutions Center Manager Forming Tools at Oerlikon Balzers, an expert for the carbon-based surfaces. Hello, Vishal, how are you today?
I'm doing good. Thank you so much. And hello, everyone, and looking forward to a great webinar. Thank you.
Okay, thank you. So now let's have a quick look at today's webinar content. We will start with benefits of aluminum stamping parts. Then Dennis will speak about what makes aluminum special and what are the biggest challenges is aluminum stampings. And our guests, uh, other guest Pedro with Vishal will speak about what solution exists. And in the end of this webinar, we will have the discussion. So you viewers, you can send us some question and we will try to answer them. So firstly, I will start. I will speak about stamping aluminum parts and about their benefits. So one of the benefits of aluminum stamping aluminum parts is excellent surface finish. Stamped aluminum parts have a good surface finish. Additionally, you can add other finishing options such as painting, powder coating, and so on. The other benefit is high strength to weight ratio. The parts are lightweight and offer good strength. That's the reason why aluminum stamped parts are suitable for the aerospace industry. The other benefit is excellent thermal conductivity, a property that makes aluminum best for cooking accessories. The other is good electrical conductivity. You can use aluminum as an electrical conductor. The other is low temperature resistance. Aluminum can maintain its toughness and tensile strength even in low temperature conditions. And the last is excellent corrosion resistance. The oxide layer protects the aluminum from harsh environmental conditions. Apart from these, aluminum parts are not toxic, inherently reflective, and easy to fabricate. The other part is Dennis' part. Dennis will speak about what makes aluminum special, what are the biggest challenges in aluminum stampings, and what solutions exist. So, Dennis, it's your part. Please jump to it. It's go on.
Okay.
Uh,
About the question, what makes aluminium special? One of the biggest special features compared to mild steel is the 3 times lower weight. It is a relatively soft and tough metal. Aluminium has excellent forming properties and high resilience. Aluminium is often used wherever weight savings and corrosion resistance are required. Not all aluminium is the same. There are many different alloys, each of which will have very different properties. Aluminium has very good thermal conductivity, but thermal conductivity can be problematic, especially when punching with high stroke rates. Aluminium expands much more when exposed to temperature than steel.
Okay. So now we will probably speak about the biggest challenges in aluminum stampings. This is right, Dennis?
Right?
Yeah.
The biggest challenge when punching aluminium is the forming of the punch of a build-up edge, which is also known as punch galling or adhesive wear. This build-up edge becomes stronger the higher the temperature rises during the work process. As soon as the build-up edge has formed, flakes will be created, which can then pose a problem for the tool and the finished part. Adhesive wear is caused by friction between the surfaces of the punch and the sheet metal plank. When punching non-ferrous materials such as aluminium, aluminium alloy, copper, or brass, material sticks on the punch. This leads to the formation of a build-up edge and later to flakes when the punch dives into the die.
Okay. So another.
Here we now see two pictures of punches with galling. Punches with galling cause fractured or broken punches, stripping problems, poor quality holes, fast tool wear, or flake generation. In these two photos, we see flakes taken from a tool in which aluminium parts were made. And this picture shows flakes in the die. Flakes refers to particles that are detached from the tool during the cutting process or released from the cutting zone and spread uncontrollable within the die and the press. The consequence are marks on the sheet metal parts. Here we see a fender with such markings, which lead to rework or scrap or damage to the tool.
Okay, so now we heard about the challenges, and now you probably tell us about some solutions. So go on.
The solutions should be to prevent the build-up edge. To counteract the galling, we must reduce the coefficient of friction between the punch and the aluminium. This can be accomplished through several avenues. Here we have listed the most common solutions. Lubrication is reducing the friction between punch and the aluminium and also reducing heat in this operation. But this acts as a bonding agent between the punch and the slug. This magnifies surface tension and increases the possibility of slug bonding and pulling. To avoid this, jack tool punches will be a great help. The benefit of using jack tool punch are twofold. The spring-loaded jack tool pin is a method to retain the slug in the die button after perforating. The jack tool punch also has a side vent hole which allows air to get in, breaking the vacuum. Also, a sharp cutting edge and the correct die clearance is required. When perforating the softer aluminium grades, significant hole shrinking may be experienced. Utilizing the proper die clearance, the amount of hole shrinking can be managed. Edge radius punch points for the softer aluminium grades should be avoided. A flat sharp edge punch point without any shear angle and the correct die clearance performs best. The shear has a tendency to only deform the aluminium and cause more rollover in the hole in the softer aluminium grades. This photo shows us standard APX punch with a roughness of RA 0.4. And on the right in the picture, a mirror polished punch with a roughness of RA 0.1, which also can be produced at our production in Portugal. Polished surfaces reduce friction in the shear zone, which reduces the cutting factor and the cutting forces. Punches with a relief grinding are the most commonly used and probably the best variant to prevent punch galling, because here the friction between the punch and aluminium is dramatically reduced. We see the XAR alteration on the left. The angle and the length are freely configurable, and the angle A is limited to 10 degrees. On the right, the XAV alteration. The L1 is the catalog point length and the L2 is the variable alteration length. This alteration is according to the VW standard. The angle here is always 2 degrees. The advantages of this: the XAR and the XAV alterations are variable for all Dayton cutting punches. We have a longer tool life with cutting tough materials, and coatings can further enhance the positive effect. These were some solutions from Dayton Progress, and now we will hear solutions from our colleagues from Oerlikon Balzers.
Okay, thank you, Denis. That was an excellent presentation. And now it is Pedro's part. So, Pedro, I know that you have two parts, so I will ask you for the first one question. Could you explain to us the reason for the collaboration between Dayton Progress and the Oerlikon company?
Yes, good afternoon. So, first of all, I want to thank Dayton Progress for inviting us to participate in this webinar. And after, I have to say some words about our company. Oerlikon Balzers is a company in the Surface Solution division of the Swiss group Oerlikon. And we have more than 100 production centers spread all over the world. And we are the pioneer and the market leader in the application of coatings applied by PVD. PVD is physical vapor deposition technology. In the Iberian Peninsula, we have 3 factories, 2 in Spain and 1 in Portugal. And besides working as an in-house center to Dayton Progress, we also service the entire industrial Portuguese market. And more than a customer, Dayton Progress has been a partner for more than 20 years. And this partnership allows us to collaborate very closely. The fact that we are in the same building and under the same roof allows an optimization of resources and process and a huge reduction in costs, for example, logistic and transport. And also a very short time delivery time. Sometimes it's possible less than 12 hours. Easy communication and fast collaboration also makes it possible to overcome any difficulties that arise. In short, it is a strong and stable relationship with a win-win result between the both companies. About our coatings, if you can, yes. For the specific case of aluminium, as you can see, our Balinit Star is the best solution. There are exceptions for the hot forming that because we have high temperature, so we have to go to another coating, Balinit Formera. But for 90% of the situations with aluminium is Balinit Star. Our Balinit coatings are extremely thin coatings, typically with 2 to 6 microns, extremely hard, typically from 200 to 3500, 2000 to 3500 HV, and with extremely low coefficient of friction, 0.1 to 0.5, And in the case of carbon coatings, we can achieve 0.1, 0.2. It's easy to see that the application of a coating with these characteristics on the top of the surface of a tool leads to multiple benefits, such as a longer service life of the tool itself, an increase in productivity, a reduction in machine downtime, and so on, which lead to the ultimate goal of cost reduction. The constant evolution of balinite coatings has allowed the study for the application of the most appropriate coating for each application and each material to be worked on, significantly increasing the performance of the tool and the effectiveness of the coating. In Portugal, we can apply a wide range of balinite coatings appropriate for different use cases. For the specific case of cutting, forming, and stamping aluminium, the best solution is the use of carbon-based coatings, which means the DLC diamond-like carbon family of coatings. Among the coatings of the DLC family, the ones we apply the most in Portugal is Balinite Triton Star. Another option is Balinite C. And I think now Dr. Vishal will be able to explain in more detail this kind of applications and advantages and of this family of coatings.
Okay, thank you, Pedro. Thank you very much.
Okay.
And yeah, finally, let me once again welcome Dr. Vishal Khetan, an academic expert who is here to showcase some of his research in the field of surface engineering. So now, Vishal, tell me how you coating industry look at the piercing or stamping problems. How do you simulate it? And why do you think the Triton Star is a good solution for aluminum standards
Mm,
from your point of view?
Thank you, Mojmír. So we in our coatings world look at the wear caused by aluminum stamping onto the tool in quite in detail, and we try to study as good as possible. So as Dennis was already explaining, whenever you are going to stamp or punch aluminum blank, typically you always have a residual oxide on top of these blanks, which then can form, and this is just an example illustration here, some kind of hard particles which then starts to scratch the tool. And this is one of the things we think is the origin of challenges which start to potentially, help build up of further aluminum onto the punch surface, which increases friction. And then hence, over a period of time, if the friction force is very high, leads to damage of the punch. And we see like these challenges quite often, and we have some good tools in-house to simulate these kind of wear mechanisms. Could you go to the next slide, please? Uh, so we have developed a nice FT application lab here in Balzers, Liechtenstein, where we try to understand the customer needs, and we have a beautiful test method which was actually developed by Applied Material Science Group in Uppsala called the load scanner test, which helps us to simulate how a typical aluminum stamping tool may behave with respect to galling, what is nothing but sticking of aluminum. And here we can use two different rods, one being the aluminum itself, what our clients want to process, and second rod representing the tool. And we rub these two rods against each other at variable loads. So the load is continuously changing as these rods are rubbing against each other. And we can clearly start to see that different surface treatments ranging from just a steel to say a coating how it will behave, how the aluminum will start to tend to stick. And these kind of simulation tests help us understand the behavior of the aluminum at first hand, and then again help develop right coating solutions. For instance, we have talked about Triton Star, that it works well for the stamping industry, giving lifetime to the customers, at the same time improving the performance and getting good quality tools, good quality products coming out while using these tools when we do aluminum stamping or aluminum punching. As the question was asked, why Triton Star is good, I would like to illustrate using this test in the next slide. Why Triton Star would be a better choice than compared to a bare steel. So we had a situation where the load scanner test was used to find a good DLC coatings. It's already explained to you by Pedro that DLC coatings or carbon-based coatings are actually very helpful in aluminum stamping and punching industry. So here you see a comparison on the left hand side, a test done with steel against aluminum 6000 series alloy, and these two rods, when they were rubbing against each other, you see in the graph a change in friction coefficient on the y-axis. On the x-axis you see the change in load, and on z-axis the number of times the rod was rubbing against each other. And when we work with, say, a steel like Orvar Supreme or many other steels which were tested with this particular test, uh, we could run maximum 15 to 20 cycles of this rods rubbing against each other, and then over a period of time the friction started to grow heavily, as you see the red color, which is showing you friction coefficient of up to 1, which originates due to galling of aluminum. Now, when you put a coating, say like Triton Star, first of all, the test could easily run for up to 200 cycles, where we stopped the test because it was not needed more. And you see the friction develops over a period of time, but there are certain load ranges like 0 to 350 Newton where we see no galling taking place. And further, at higher loads also, the galling is not significant enough as we see for a bare steel, making Triton Star an ideal solution for aluminum punching and stamping applications. So these kind of tests have helped us to work with our clients in a good way to choose the right solution for them. Triton Star being one of the best, I would say, average solution. And if there are special needs or we need to modify something, check it out. We can do it directly with our clients using this kind of tools which we have available in-house.
Okay.
And finally, we just go one step deeper here to show you how a coating really protects the tool. So we have seen that again, the main challenge in punching is the scratches which get initiated due to different particles or residues which are released during the punching process. Uh, they start to generate scratches wherein the aluminum will build on top. But when we visualize this sticking process, it was seen that DLC coating, first of all, can resist the whole scratching process much better than steel. Point number one. Point number two, we always see that the coating is always intact. It's always about the surface where the sticking takes place, and hence the tool is protected. Well, we do not damage the tool right away. One can always clean up the aluminum if the galling is heavy, or we can change the coating type. But we always see in aluminum forming a cutting that majority of the cases, the wear, once you use a coating, the wear reduces significantly, and that's how we cooperate with Dayton to give these coatings on top of their tool to give our clients the best performance they need in terms of quality of product produced, in terms of the lifetime of the tool, in terms of having better machining time, processes with lesser downtimes. Thank you.
Yeah. Okay. Okay. Thank you very much. It was fascinating. Thank you. And now we have the time for the questions and answers. So if anybody needs to ask our guests for anything, please use the comments and send us some questions. Before that, I have one question here for Dennis. Look, even minor galling appears on the tools during large volume stamping operation, is immediate maintenance required, or we can wait until the galling is more serious? Dennis, can you explain us?
Yes, I can say something about it. And it's not good to wait until something immediately maintenance is required, because if it starts, then it's get more heavy and the problems are getting bigger. So in this case, it would be great when we get in contact, or the customer can contact us, and we can check the most important things. First of all is what kind of aluminium is in use, what is the die clearance, what is the dimension of the punch, how thick is the material, and how many hits they are doing per minute. And then we can create a good solution, I think. And that could be something maybe with a back taper, maybe with a coating on it. But first of all, then we need to know what's exactly done, and then we can prepare a good solution.
Okay, thank you very much for that. I see that we have no questions for now. I will wait for a while if somebody will send us some question. And yeah, maybe if you, Dennis or Pedro, will want to ask you for Vishal for something, you can. We will wait until somebody send us something.
About the last question, if I can add something, if the punch has a very small wear, it's good also, or we have the possibility to remove the coating and do a small polishing and do a new coating is possible. But if we have a big wear, so we have to do a new punch. Okay.
Yeah, I have some question here, so I will put it here. So does it make sense to use both stepper and coating together? It's, I don't know if Dennis or Vishal will answer.
If I should answer, of course, yes. These are the. It depends on what aluminium or what aluminium alloy we are using, but in the end, this is where we really have the best results with. Yes, to have the back taper in combination of a coating, and then mostly it is the 3-tone star coating.
Yeah. Okay. Thank you for that. So it looks that nobody will send us any questions. So yeah. So maybe it's a time to say goodbye. So thank you very much for your attention. Thank you, viewers, to attend us, and you guys. I hope that we see you each other next time. And once again, thank you. And yeah, if you want to say something, please do it, because we are, maybe there is another. No, it's not. So thank you and have a nice day. Can you say something more? Please do it.
Thank you to all our viewers.
Okay.
Thank you, everyone.
Yeah.
Thank you for the side of Oerlikon Balzers.
Yeah. Have a nice rest of the day, and goodbye.
Goodbye.
Bye.
Bye.